Hello and welcome to Code Pro, where I teach you how to code, make apps, and share technology. In today's tutorial, we are going to be learning how to write Swift on the server using a framework called Perfect. This tutorial will have two parts. The first part, we are going to build the server, and in part two, we're going to build the iOS app that can talk to the server and communicate back and forth. So if you love Swift as much as I do, then this is really great news. All right, enough chit-chat, let's begin.
Head on over to perfect.org where we can read the documentation for getting our server set up. So go to the Get Started guide here and let's take a quick look at what we need to do. So we're going to be running this using Swift 4, so you're going to want to make sure you have Swift installed. And as far as the environments, you can run this on a Linux machine, but you'll need to follow the instructions to do so. I'm going to be running mine on my Mac just because it's a little bit easier for this tutorial. And if we scroll on down to the Build Starter project, we want to copy the command that's listed here, and we'll go ahead and open a terminal and paste that in, and execute that command, and let that download and get set up for us. That might take a little while to download and get set up, but what you should see is once you run this command, the build debug perfect template, you should see a starting HTTP server localhost on 8181 port. So if you see that, you're good. It means your server's up and running and listening. And we can go take a look at the server code right now and go ahead and add some custom endpoints. Navigate to the directory where the perfect template project was downloaded and open that folder. And inside, you'll see the sources files, which are main.swift, and a few other files in here too. This is where all the server code is going to live for our project. If you go back to perfect.org here and you look at the documentation, there's a step here for generating an Xcode project. So let's go and run that really fast from the terminal. Go to your command line and make sure you are inside of the directory for where that project is. It's very important. And then go ahead and type the Swift package generate -xcode proj. And we'll let that run. And that generates the Xcode project for us. So let's go ahead and open that now and take a look. Go up and change your target and make sure the perfect template target is selected, not the package. And with that target selected, go ahead and hit the play button to start it. It'll probably compile it on your machine. And what you should see here is the same message that you saw from the terminal. Server localhost is running on port 8181. Let's take a look in the project here. We have a package.swift and we have a main.swift that are already filled out for us a little bit. And we're going to make some modifications to both of these files. Let's go back to the documentation for Perfect. And if you go into the Getting Started from Scratch section here, the first thing that they're going to kind of inform you is that when you open the project, you're going to want to make some modifications. And starting in the package.swift file, we're going to take what they have here in their example code and basically just paste that and replace what is already in the file with the latest documentation that they're giving us. So we're just going to simply do this, and if we take a look at what we have here, we have the package with the name, and from their documentation, My Awesome Project, but you could name that whatever. The dependencies, which is the perfect HTTP server, the 3.0 version of it, which supports Swift 4, and then the targets included here, which is also pointing to the name from up here as well. And let's go back to main.swift and go back to the documentation here. And there's also another example of what to do here. So I'm going to replace what they have with the updated documentation from here. And I'm just going to copy this and just replace everything in the file. And sure enough, okay, so we have everything set up here. Let's make one other modification here. Down in this do block, they have the name of the server, example.ca. I'm just going to change mine to localhost. I'm going to leave the port the same. Now, I'm not quite sure why their documentation differs from what the sample app from GitHub has in it. I'm guessing they updated something but didn't update the project, so I'm just following what the latest documentation seems to point out to do. So after we've made all these changes, we want to make sure that everything still works, so let's just go ahead and run the server. and make sure that we see that the server starts, which is good. Next, we want to test this from the browser. So go to your main.swift file, and I'm going to go ahead and put a breakpoint on line 28 here. And you'll notice that this is a get method, and because it's a get method, we can execute this and the browser will actually spit back the response. In this case, it's returning back some HTML that just says hello world. So if we see this show up in our browser, then we know everything is good. So I'm going to open Safari and go to localhost :8181 and hit enter, and oops, make sure the server's running. So make sure your server is actually started, otherwise you're going to see what I just saw. And it's running. Go ahead and refresh the browser, and we'll hit the breakpoint because we got the call from the browser to localhost. And if we let that go and step through it, and we go back to our browser, you can see that hello world shows up. So we just saw, okay, here's the client that made the request, the server intercepted the request and spit back the response. But what if we wanted to use JSON instead of HTML? Well, that's not a problem either. If we go back to the documentation under the Getting Started guide, you can see under the section Returning JSON Data to the Client that there's a little code snippet here that we can follow. So I'm going to take that code and just go back to our method here where we have the HTML, and I'm going to just delete the HTML part. I'm going to paste in the JSON part, and I'm just going to change a couple things here. Instead of D, I'm just going to call that JSON response. I'm going to update it here as well, and I'm going to change the JSON payload to be something a little bit more simple. I'm just going to say is server alive, and I'll just set that to true, and that's going to be our payload that we send back. And let's go ahead and run that and see what we get. So make sure perfect template is selected and hit start, and we can go to a browser, and I'm going to refresh my local host, and look at that. So the JSON is coming back, is server alive, set to true. Now let's build our own custom endpoint. Our endpoint is going to take in two numbers that the client application is going to send it. It's going to add those numbers together and then return the sum of those numbers in the response. And similar to how we have an endpoint defined here for us by default, we're going to make our own from scratch and use this as a model. So we're going to go right below and do a routes.add method, and this is going to be a .post, and URI is going to be different as well, and that's going to be called /add. It's going to be a post because we're going to be sending something to it. We're not just going to be returning a response back. And what we want to do next is put in the request response for the closure. And let's copy some of this right here that we can reuse, and we'll make some modifications. So we're going to put that here, and I'm going to change the response JSON. What we'll start off with is a mutable dictionary. So we're just going to call this var response payload. And instead of the values in here, I'm just going to start off with a sum assigned to 0. So it's 0 by default until we run a computation on it and return a value back. So let's update where we set that response in here. And so far so good. So that's pretty familiar to us. One thing we need to do is get the numbers that the client application is going to send and add those together. So I'm going to assume that the client is going to send parameters called operand 1 and operand 2. So I'm going to look for those by the name. So if let operand 1 equals request.param by the name operand 1, and we also need 1 for the right-hand side number. Let operand 2 equal request.param for the name operand 2. So if we have those values, let's go ahead and do something. And what we'll do here is, if you'll notice that these are type strings, we're going to need to convert them to ints. So I'm just going to do this. If let left-hand side, or LHS equals int operand 1, as well as let right-hand side equals int conversion of operand 2, which is also a string. If both of these cases succeed, then what we're going to do is say response payload for the key sum, which has a value of 0 right now, will be updated. It'll be updated to the left-hand side plus the right-hand side. And let's just go ahead and clean up the spacing a little bit here. And so we assign that in the dictionary here, and we set that back in the response payload, so that sum will be computed for us when we go ahead and run from the client application. And what we can also do here is print out the sum. The sum of the numbers is response payload for the key sum. And what we're going to do next is to actually test this in our application that we're going to build. And let's go ahead and start building that piece right now. Now for the web client piece, go into Xcode and create a new single view iOS application. And go into the main view controller. And what I've done is I've already stubbed out some of this busy work so that we don't have to spend too much time in the tutorial here. But basically I added 3 text fields, one for the left number that we're going to send, the right number that we're going to send, and then the response that we're going to get back will go here, and then a button at the bottom to actually add it. And I hooked up the IB outlet connections right here, and for the button as well. And I just do some formatting to make sure that I get the numbers back as integers for the left and the right hand side, and then we'll start here with our implementation. So if you want to get caught up, just pause the video at this point. Feel free to copy anything along and get set up, or you can just hard code it in your view controller, and then we can go ahead and implement this piece here. So now let's actually add these numbers together. So we're going to call our add numbers function at the bottom here. So add numbers, pass in number 1, and number 2. And at this point, we're going to be making the network call to our server to run the computation and spit back the result for us. Now we'll go and start implementing that network call. So let's go back up to the top here and create a new private variable. Private let endpoint equals to http://localhost:8181/add. And if you remember, the reason we use add is because that's how we're going to differentiate which route we call. If we want to call add, it needs to be different than just calling the base URL, because if we call this, we'll get back the JSON response in the browser that you saw, not the actual adding or the sum or the addition that we want to call. So we want to make sure we use add here. And so we'll keep a reference to that. We'll also do a private let URL session equal URL session.shared. And we'll just hang on to an instance of that. And let's go back down into add numbers here and start building that piece out. So we're going to do a var parameters, or let parameters equal operand 1, because that's what we're looking for on the server by that name. And we'll set that to number 1. And operand 2 colon number 2 right there. So let's build the web request part. Guard let URL to execute equals a URL for a string. And we'll use the endpoint variable we defined above, else, if we can't build that because it's an optional initializer, return. So assuming we get past there, we're good. Var web request equals a URL request for the URL, and in this case the URL to execute for us. One other thing we want to set here is the actual HTTP method. So web request.http method Let's see here. Looks like I have one too many. There we go. Web request.http method is post. And post, because that's what I defined in the server for the type of request to be sent. Now, if you're not familiar with post, get, put, and delete, I suggest you just do a Google search on RESTful APIs and understand the different types of methods that you can use when communicating to a RESTful API web service. I'm not going to go into that too much right now, but let's continue constructing the request here. So we need to also do a web request format. So web request dot add value. And this is going to be application /x www form URL encoded semicolon char set equal to UTF-8 for header field content type. And we're basically just saying that our request is going to be formatted in a particular way that the server is going to be able to understand and be able to handle when we send that through. The other thing we need to do is actually build out our parameters, number 1 and number 2, in such a way that our server can understand them when we send them across the wire. So what we're going to want to do is let URL params equal our parameters, and we're going to do a .flat map, and I'm going to shorten this a little bit to look like this. So we're going to have inside the closure key comma value in, and we're going to do for the key equal, and then value, and close that off like that. And we'll close up the space here. Dot joined separator ampersand. Okay, and that's basically putting our parameters in a format that the request can understand. Otherwise, on the server, we won't be able to actually intercept that response the right way. And it looks like I spelled that wrong. Okay, we're good there. Let's continue right along here. So we have just about everything built. We need to actually set the web request.http body, which is a data type. So that's going to be our URL params .data, and we're going to do the overload for the using and allow lossy conversion. So I'm going to do .utf-8 and true there for allow lossy conversion. And finally, we are ready to build out the data task, which we're almost there. So let data task equals our session, the URL session from above that we created up top, .data task with the web request, or the URL request that we want. And we want the completion handler. So we want this overload here. So we're just going to use the web request. And for the closure, just go ahead and hit enter. And let's go ahead and stub these out. So optional data returned, optional response, an optional error, if anything. And finally, the last piece we need to do is data task.resume. If you forget to do the .resume, it will never run the request. So do not forget that piece. You're going to wonder what the heck is going on. The flow of execution is going to be, this sends our request off to the server. Our server gets the request, adds the numbers, and then kicks back the response. And that response comes right through this closure here. So what we want to do is we want to know, okay, when we got a response back, so print response received from the server. Next thing we're going to want to do is check everything we got back. So guard let data equals data, let response equals response, because these are optionals. and that assert the error, if any, equals nil. If any of these don't come back as we expected, then return and do nothing. Once we get past that point, we need to get the JSON from the response. So what we'll do here is we've got to put that else there. Can't forget the else. So let JSON response equals JSON serialization dot with JSON object with data. And we're going to give it the data that we got back from the response. For the reading options, I'm not going to specify any, so I'm just going to leave those empty. And this can throw an exception, so it needs to be wrapped in a do try catch block. So do first of all try this, see if we can do it. I'm going to cast this as a dictionary, so string and any. I'm going to put it in a try block here. I'm going to catch anything that goes wrong here and print that out. Now let me move this up one line because it's starting to break my autocomplete here, and I'll just print oops, should be a do, not try. There we go. Print error.localize. Now this should work. There we go. Okay. Well, let's just parse our response, and we're almost done. So guard let sum equals JSON response for the optional key sum, which is what the server sends back. We're going to cast this as a string because we're going to bind it to the text field's text property. Else return. And we've got that set up so far, and I'm just going to silence this warning here because I'm not using response. I'm just going to put an underscore there. And I need to update the text field's text property with this sum, but since URL session can run in a background thread, we want to make sure that we update that UI element on the main thread. And we can do that quite easily by doing dispatch queue.main.async. And self.sumField.text gets assigned to the sum. And just to avoid any potential retain cycles, I'm going to do an unowned self here inside that closure so we don't have any potential problems there. Let me just close this off here. Let me just build this, make sure we have no warnings. There we go. Okay, a little bit of a delay. And one final thing here, otherwise your request is never going to run. Because this is running over HTTP and not HTTPS, the iOS will straight out reject your web request and it'll never get through. So we need to make one change in the property list to get around this. And if you go into your info.plist and go here, hit the plus icon, we want to look for application or app transport security settings. And you're going to want to select that to create a new key value pair there. And we want to click off of it and then expand it and go ahead and hit the plus icon there. And see, there's going to be exception domains, allow arbitrary loads, and allow arbitrary loads in web. We're going to do allows arbitrary loads for the tutorial, which lets any unsecured request through. In production, this is a no-no. You're going to let through specific domains, but this is just for testing and education, so that's okay for right now. So we have everything set. Let's go ahead and start up the server. So make sure the server is running. And with the server running, let's go ahead and put a breakpoint into the add method here, and we're going to put them side by side. And let's fire up our simulator and send the request and see if it works. Actually, I need to make a few minor adjustments really fast before we run this. Go back to your JSON response, and instead of a string, that's going to be an integer because that's what the server sent back. And when we assign it here for the text field, we're just going to convert it to a string, sum. And one other error we need to change is number 1 text should not be using number 2s, it should be using operand 1. And we're good now. So go ahead and start the simulator and let's see what it looks like. So I'm going to try adding 9 and let's just say 10. And before I do the add, I'm going to put a breakpoint in the server. And notice my server's not running, so make sure your server's running or it won't get hit. And so we're listening on our port. And back over here on the simulator, I'm going to go ahead and hit add, which makes the call. And server got it, so let's let the server run. Server tells me that the sum of the numbers is 19, and the result I'm getting back here is sure enough 19. So it's working, end-to-end communication here. Let's try, I don't know, 25 plus 100, and go ahead and run add, and wait for the response. It looks like I killed the server by accident there when I killed the breakpoint. Let's run that. So 125 there. Verify the server's still up and running. Let's try a different number here. 34 and 100. 134. Okay, so far so good. And how about 2 plus 2? It's 4. So everything's working. We have an app that can send up a network request to our server. Our server can run some logic and send a response back. Our app can intercept and parse that response and display the data.
And that wraps up our server-side Swift tutorial. So if you found this tutorial helpful, go ahead and smash that like button, follow CodePro on social media, and make sure you subscribe to CodePro. And let me know in the comments section down below, what is your favorite server-side stack? Thank you so much for stopping by, and I'll catch you in the next one.